G'day, I'm Marco and welcome to Swift Almanac, where we teach you the basics of Swift in 10 minutes or less. Today's lesson is Enumerators, or Enums for short. So let's have a look at enumerators in 10 minutes or less. Enumerators. Enumerators in Swift are much more broader than the C-style enumerators, which can only contain integer values. An enum, or an enumerator, can have merely a label, or the labels can be values such as strings, ints, or any other data type, and each enum can be of a different data type. Now, what exactly is an enumerator? Well, what you can do is you can think of an enumerator or an enum as a data type with a defined list of values. So it's basically a subset of a larger data type, and in Swift, as all of the enums can have, or the enum values can have different data types themselves, it can get quite complex. But let's have a look. So the classic example is a compass point. So if I could just spell. We've created a compass point, and the values, of course, are north, south, east, and west. And another example would be the planets, and we can have values for the planets, and we'll have labels: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So if we want to allocate an enum, we can just set that variable to the value of the enum compass point dot east. So we don't know what dot east is. Is it 90 degrees or whatever it is? It's just a label or a value for that data type, so that we can identify that compass point as opposed to something that's north or south or west. So we can change the value of the compass point or the enum by inference. So we can go direction ahead equals dot west, and I suppose enums are basically used in switch or in if statements. So you could do something such as this. So you can switch on the value of direction to head, and we could go case dot north. We could print north, and the default case is print not north. And of course, we've set direction to head to be west, and so it's not north. And the same can be done with an if statement: if direction to head equals dot north, etc. So an enum can only have one value. So if we create a complex situation where we have a barcode, but we're not quite sure of which coding the barcode is displayed as, then we can set the barcode so the barcode, or the enum, can only have one value. So we've set up an enum here with barcode with one case where it's a tuple, a UPC tuple of 4 ints, another case where it's a QR code with a string. Now we can set a product barcode equal to the barcode.upc with this default initializer, and then we can change that product barcode to a QR code of the string A, B, C, D, E, F, and product barcode is now a string, so the data type has changed, as opposed to previously when it was a tuple when it was initially declared. So you can change the data types. You can have multiple different data types within an enum, but the enum itself can only have one value. Now, you can also associate raw values with enums so that, as opposed to here in compass point where north, south, east and west were merely labels, you can say that, for instance, some ASCII characters, this enum is a type character. So for a tab, we're going to have /t, a line feed, we're going to have /n, and a carriage return is /r. And essentially you can also infer numbers where you can go, well, we've got the planets which are integers, and so we have the case where Mercury is 1, Venus, Earth and Mars, well, those are going to increment, and then we can look at the raw values of all of these enumerator values. So we can set the planets.mercury.raw value, you can see here is 1, and the planets.venus.raw value is 2, and if we placed the planets.earth.raw value, then that's going to come up with a 3. And if we look at the compass points, when we call them a string type, then the case of north, south, east and west, compass points.north.raw value is going to be equal to north. And if we do compass points dot east dot raw value, that's going to give us a lovely value of east. So here, when we've created the fourth planet, we're using the value of 4 in the initializer, and that's going to return a value of Mars. And here 5, well, 5 doesn't exist, and so the planet's raw value is essentially going to fail, but it's going to return an optional, which will be nil. So when we print out fourth planet, it prints out Mars, and when we print out fifth planet, it's going to fail. So we've got this default thing for the string, which is going to place no value there. Now, if we were to place Mars, Jupiter is next, I think, up here, then when it all prints out, Jupiter will now exist because our enumerated case goes up to the integer of 5. Anyway, that's enums. I find them quite confusing, and I tend not to use them if I can avoid them. But essentially, if you've got a restrictive range that you know of in advance, then you can use enums to ensure that you don't get to situations where an out of range value is being supplied. Well, that's it for enumerators. If you have any questions about the tutorial, then please leave a comment below or hit me up on Twitter @SwiftAlmanac. Please subscribe to the channel, it's free, and check out our website at www.swiftalmanac.com. Thanks for watching, and we'll see you next time. Cheers.